times at the most. So we move to our topic now with introduction. Correct. Just a minute, I need to stop the sharing because my slides are not operating. Okay, I will once again share it.
Okay, sir.
Yes, it's okay now.
Ah.
Indian scholars since Vedic times use three terms like gunana, gunaka, gunya, and pratyutpanna respectively for multiplication. Gunana means multiplication, gunaka means multiplier, gunya means multiplicand, and pratyutpanna means what is obtained as a product of that operation. That's why the word pratyutpanna is used. This is a very technical word in Sanskrit, which is used for what is available after the multiplication. Then there comes a Brahmagupta, then Sridhara in 7050 AD, then Mahaviracharya 850 AD, then Bhaskaracharya 1150 AD, Narayan Pandit, and so many, deliberated on various methods of multiplication. Usually we have only one or at the most another method. But the speciality of Indian mathematicians is they used to give the methods of multiplication according to the patterns. Of course, today that is not, we are not going to study it today in details, but just I'm mentioning that such as a development of the subject. Then comes, of course, Swami Bharati Krishna Tirthaji, who in his book Vedic Mathematics discussed methods of multiplication, 3-4 methods again, and the sutras which were used, one of which we have studied, Urdhva Tiryabhyam, vertically and crosswise, and Nikhilam Navataha, Charamam Dashataha, all from 9, last from 10. I'm sure you must have studied both the methods in the previous classes. This Urdhva Tiryak method has some bearing on some parallel in what they used to call Vajrabhyasa method or Tastha method in our Indian history. They are similar, not exactly same, but we can at least say that there is some similarity between the methods earlier stated and the Urdhva Tiryak methods said by Bharati Krishna Tirthaji in his book. But same method applied to algebraic multiplication, means multiplication of two polynomials, is again a contribution of Swamiji. This Urdhva Tiryak method has tremendous potential, which is applicable in various disciplines of mathematics. I am sure last lecture explained its use in multiplication of numbers. Today we study the use of mixed operations like sum of the products a into b plus c into d for numbers as well as for the algebraic expressions. Let us have a quick revision of what we had done yesterday so that we can carry forward the same for the multiplication which we are thinking about. I generalize what you have studied yesterday. Consider a n-digit number with digits an minus 1, etc., a3, a2, a1. a1 is unit place digit. That way, the units will move to left order. And now I want to multiply this n-digit number by a single digit number, say m. My multiplier is m-digit number. So there will be n parts for it because n digit are there and multiplier is a single. N parts will be written like this. Somebody is playing with the things. Again, Yes. The multiplication will be like this. M multiplied by n, highest place digit, first part. M into n minus 1 second part. And it will go up to unit place. M into A1. It is just a theoretical representation of what we have done yesterday. Please write this way so that we can apply it easily. M into n minus 1, second part. The colon between the two denotes that they are the parts and not the digits. They are the parts, remember. M into n minus 2, and it will go up to m into an. After writing the parts, individual multiplication, then we will add them from right to left part-wise. Just have an illustration. The things will make clear. 5 multiplied by 2614. We write the parts either from left to right or from right to left, any one way. I prefer left to right. So 5 into 2, 10. 5 into 6, 30. 5 into 1. For shifting the digit, instead of writing 5 only, I set 0, 5 so that every part should have 2 digits. And the last, it will be 5 into 4, 20. So I need to write the parts horizontal way directly, whatever answer comes. And of course, a single digit multiplier, we need not do anything more. The parts can be written easily. After writing the parts, now I start adding the parts. But that addition should be from rightmost, that is 20. That 0 from 20 is kept as it is. 2 is shifted to and added to 5. That becomes 7. So 0 as it is. 2 plus 5. 0 plus 0 of the 30. And 3 plus 10. That is 13. So final answer will be 13070. I repeat what I am saying. 0 as it is. 2 plus 5, 7. 0 plus 0, 0. And 3 plus 10 is 13. So final answer will be 13070. So instead of treating with the carries and remembering it or directly or writing it somewhere and then collecting, Swamiji asks us to write the parts, whatever answer comes, and then add part-wise from right to left by shifting extra digit. While we shift the digit, every part we will retain one digit and move the remaining digits to immediate left part. Second example, 8 into 183,724. Start writing. 8 into 1, 8. 8 into 8, 64. 8 into 3, 24. 8 into 7, 56. 8 into 2, 16. And 8 into 4, 32. They are easy to write because, again, I repeat, multiplier is a single digit. That's why it is easy. After getting 6 parts, because there are 6 digits and multiplier has 1 digit, so there will be 6 parts, I start transferring. From 32, I write 2 and shift 3. That becomes 19. From 19, I will write 9, shift 1. So 56, 1 plus 1 becomes 57. I write 7 and shift 5. That becomes 29. Retain 9, shift 2. That becomes 66. 66, 6 in the answer line, and 6 to plus 8 gives 14. So final answer 146,972. I hope now the things are clear. Every part should have 1 digit. Remaining digit is to be transferred to immediate left part and added, so that even this can be done mentally. Once we write the parts, you can say 2, 9, 7, 9, 6, 14. Enough. Just we can always transfer after good practice. We can always transfer the digits mentally and start writing the answer in a line. One more example. Sum of the products one digit multiplier. Now we come to our topic. We will be doing product and sum simultaneously. So the problem will be of this type: m into a, say, plus n into b. What we will do is we will write the parts of a first. Below that, in the second line, we will write the parts of n into b plus wise. And then vertical addition first. Like this, parts of a, m into n minus 1 up to m into n. Assuming that digit b is also n digit number, we write the parts of n multiplied by b like this: n into bn, n into bn minus 1, n into bn minus 2 plus wise. Because there are n parts, we can do that. If the parts did not match, then we will write accordingly plus wise. We will see the examples that way. But here at least we are assuming that a and b have n digits. After writing the parts one below another, now we add vertically. Means we will add MAN plus NB1, write the answer. MA2 plus NB2, write the answer. And we continue up to the leftmost part, MAN plus NBN. After getting n parts again, addition, now we shift the digits as in the previous example to write the answer. So what we are doing here, we are not actually finding the value of m into a, just writing the parts. We are not finding the value of n into b. We are writing the only parts, but one below another place wise, vertical addition and horizontal shifting. I have some 2-3 examples now. See, find, write the example, find 6 into 324 plus 9 into 571. Start writing the parts for first product. 6 into 3, 18, 12 and 24. Plus below that, in the second line, again 3 parts. 9 into 5, 45, 63 and 01 for our convenience. Or write 9 below 4, any one way. Now add vertically. You can add left to right, right to left, no issue. So 24 plus 9, 33. 3 plus 2, 5, 6 plus 1, 7. You can add that way also. 8 plus 5, 3 and 4 plus 2, 6. So vertical addition gives me 3 parts. 33, middle part 75, left part 63. Now I add horizontally as in the previous case. So out of 33, I will write 3 in the answer line. 3 plus 5, 8. Then shift 7 to 63. That becomes 70. So 3 plus 5, 8. 7 plus 3, 10. So that becomes 70. So my answer is 7083. Observe that we are not calculated what is the answer for 6 into 324 except the parts. Without finding the answer, we have a direct answer for the sum of the products. Initially, we will be dealing with some simple example. Then we will be going to 2 digits, 3 digits, so on. Try this. Find 4 into 1579 plus 7 into 420 plus 6 into 78. We will write 4 parts for the first product. 4 into 1, 4, then 20, 28, 36, this way. Now observe that there are only 3 digits. So I will not write product 7 into 4, 28 below 4. No, I will start writing below 20. So first part 28, second part 14, and third part of course 0, 7 into 0, 0. I will write like this. So arrangement will be always place wise. That is what I mean to say. Then for the third product, there are only 2 digits, means 2 parts. So 42 and 56, sorry, 42 and 48. I will write below second place digit and unit place digit. Once 3 parts are arranged properly, If you do not write this way, then the answer will be wrong. So always remember to write the product plus wise. Now vertical addition. 84 for first, 36 plus 48, 84, 24 plus 14 plus 42. Do by your way. Answer is again 84. 20 plus 28, 48 and 04. So I have 4 parts for my answer. Now usual shifting. 4 as it is. 8 plus 4, 2 is 12. I will write 2 and 1 plus 8, 9. I will shift to left part. That gives me 57. Out of which 7 I will retain. Transfer 5 to plus 4. Answer is 9724. Once you have a good practice, you can jump over the steps, definitely. But don't hurry about this. बहुत जल्दी नहीं करना है पहले. Go slow. Once you have a good command over the situation, then you can write the answer as easiestly and as fast as possible. Now try this. Write the parts. Now 14, 11 and 15 are the multiplier. They are smaller one, enough smaller. We know the multiplication table for 14, 11 and 15. That's why I have considered the example. You can directly multiply 14 into 5, 70 that way. Start writing 70 first answer, 98 second, 14 into 9, 126. So this is the first example where a part has 3 digits. Don't worry. While writing the second part below the first set, we will take care of writing 11 into 4, 44, 11 into 8, 88, 11 into 9, 99. That is to be written like this, below 26, not below 12. Or you can write 099 for a safer side. Same thing for the third product, 15 into 7, 105. Proper placement. 15 into 1, 15, 15 into 2, 30. This way. So 105, I will write 05 below 44. That is to be taken care of every time. And we have a habit of doing this. Nothing new we are doing. Now vertical addition. 9 plus 6, 5. 12, 9, 3 gives me 24. So 2, 5, 5. 98 plus 88 plus 15. 8 plus 8 plus 5. 2 plus 1 plus 8 plus 9. That is 20. Then 4 plus 5, 9. 7 plus 4, 11 plus 10, 21. Now I have 3 parts. Every part has 3 digits. Observe the difference. In all the previous problem, every part used to have at the most 2 or 1. But the rule remains the same. Out of 255, I will retain 5 and shift 25 to middle part. That will give me 2, 2, 6. Then I will retain 6 and shift 22 to left part this way. Retain 5, shift 25. Then 2 to 6, retain 6 and transfer 22 to left part to have the final answer 24165. I hope everybody is understanding what I am explaining. Just example for practice. Just write the example and see. You can get the answer. I will wait for you for a minute. Start. Even if you don't complete it within a minute, don't worry. Just note the answer and then try at your time. You can write the examples at least as an exercise or practice examples. Last example has 4 sums. So we will have to write 4 sums, one below, for 4 parts, one below another of the product. 20 into 308. That is not difficult. 20 multiplication table is known, 15 is known, 8, 13, no issue. Just note the answers and check whether your answers match with me or not. Now we move to the next case of our sums of products. Difference of the product. Up till now we used to add. Now see what is the difference. But before going to the difference, Vedic mathematics has a special notation for negative number. That notation we will study first, and it is called bar digit or vinculum numbers. What are these bar digits? What is their significance? Try to understand with little more concentration. We have a case 8 minus 3, 5 plus 5 only because 8 is greater than 3. Answer is plus 5. But when the 4 minus 7 is case, we call it minus 3. In Vedic mathematics, minus 3 is equivalently, not always, equivalently written as bar over it. Bar 3. By bar 3, we understand it is minus 3. It is called, in Swamiji's notations, vinculum number or vinculum number or bar digit simply. So whenever there is a bar over a digit, we understand that its place value is negative. Now 43, we know that 4 has a place value 10. That's why it becomes 4 into 10 plus 3, 43. But if I write 4 and bar 3, so one digit positive, another digit negative. This is a completely new case. We either write minus 43 or plus 43. But this is a case where 4 is positive place value, 3 has bar over it, so it has a negative place value. That's why I do multiply 4 into 10 because it is 10's place. But plus bar 3 means it becomes 37 because plus bar 3 means minus 3. So 4 bar 3 means 37. We can, after practice, 4 bar 3, 40 minus 3, 37. That way we can remember, we should read it and we should understand it like this. Let us take one more example. 7 bar 1, 5. Two positive digits, 7 and 5, place value positive, but middle digit is a bar digit. So positive digit is to be kept as it is, 5, and 7 bar 1 is to be read as 70 minus 1 or 695, or I can say 7 into 100 plus bar 1 into 10 and plus 5. Plus bar 1 into 10 means minus 5. That's why it becomes 70 minus 1 and plus 5, 695. Because we don't have the habit of working with these numbers, initially you may face some difficulties, but have a patience. These vinculum numbers plays very important role in calculations. 5, 4, bar 1, bar 4. So 4 is the leftmost positive digit. So I will keep 5 and 400 minus 14. Bar 1, bar 4. Two bar digits consecutively there. So I consider them as 400 minus 14, 5 as it is, 5, 3, 8, 6. Now we go to our problem and apply those vinculum numbers if they occur. Every time they will not occur, but if at all they occur, they play a very important role in calculations. So example is 7 into 197 minus 3 into 112. As usual, we write the product, except that we will subtract instead of add. So products are like this. 7, 63, 49 and 3. I'm purposely writing 03 and then 06. Just to avoid any confusion of the place. Now vertical subtraction. Remember, vertical subtraction. So 9 minus 6, 3. 4 minus 0, 4. Do digit wise. Don't try to do 49 minus 6. do digit wise. 3 minus 3, 0. 6 minus 0, 6. 7 minus 3, 4. So 3 parts, no bar digit is occurring only because upper part has bigger digits than the lower part. That's the reason, of course. And usual shifting will give me 1, 0, 4, 3. 3 as it is, 4 plus 0, 4, 6 plus 4, 10. So answer for subtraction, total subtraction, 7 into 1, 9, 7 minus 3 into 1, 1, 2 is 1, 0, 4, 3. Now this example, yes. Find 4 into 879 minus 5 into 233. Write the parts, do fast. 32, 28, 36 minus 10, 15, 15 this way. Don't add, subtract. Again digit wise. 6 minus 5, 1. 3 minus 1, 2. 8 minus 5, 3. 2 minus 1, 1. 2 minus 0, 0. 3 minus 1, 2. Again, no bar digit appearing. Shift the digit to have the answer 2, 3, 5, 1. Next example. 7 times 197 minus 3 into 58. Observe that the subtraction has two digits, only 5, 8. So I have to place the digit parts accordingly. First part, 763, 49 minus 15 and 24. I will write below 63 and 49. Vertical subtraction now. 9 minus 4, 5. 4 minus 2, 2. This much is all right. Now, instead of 63 minus 15, of course, you can write directly by taking the carry digit. But if I wish to use the bar digits, the parts will be like this. 3 minus 5, bar 2. 6 minus 1, 5 and 7. Or you can say 48 straight away. No issue. But have a little bit practice of bar digits. Now shifting. 5 as it is. 2 shift added to bar 2 becomes 0. 5 shifted to 7 will become 12. Answer is 1204. Of course, with 48, you are going to get the same answer. Whenever bar digit occurs, it is better to use it. In simple example, of course, that doesn't make much difference. But when we will be studying addition and subtraction simultaneously, at that time, use of bar digit is always helpful. Let us see one more. 4 into 727 minus 6 into 238. Write the products. Now I have written the product. Because I want to subtract those parts, every digit I am writing as a bar digit. In a previous example, I used to write minus and all plus digits. But now I am writing plus and every digit bar digit so that I can subtract easily. 8 minus 8, 0. I will not forget to subtract due to that bar. Start vertical subtraction from right side. 8 minus 8, 0. 2 minus 4 bar 2. 8 minus 8, 0. 0 minus 1 is bar 1. Remember, 8 and bar 2 will give me 6. 2 and bar 1 will give me 2. 1. So the answers of the vertical subtraction is like this. If you are not comfortable of writing every bar digit, then you can write the minus sign and subtract. As I said, no issue. Now shift of digit, 0 as it is, bar 2 plus 0 will be bar 2, and bar 1 added to 6 will become 5. So 1, 5, bar 2, 0 is my answer. Of course, this is not the way we understand the answer. So I will transfer it to normal form, from bar digit to normal form. 0 as it is. 5 bar 2 means 50 minus 2 is 48. So answer is 1480. Or you can say 150 minus 2, straight away 148. No issue. Whatever way you want to observe that bar digit. Either you can say 550 minus 2 or 150 minus 2 to write complete answer 1480. 5 times 8964 minus 2 times 1247. Write the parts 40, 45, 30, 24. Your way of writing, you can write minus or all bar digits, any one way. I have written all bar digits. You can write minus and 2, 4, 8, 1, 4. As a now vertical addition in this case, of course, bar digit means a subtraction always. 0 and bar 4 will give bar 4. 2 bar 1 means 1. 0 bar 8 means bar 8. 5 minus 4 is 1. And 40 minus 2 is 38. Or you can say 4 bar 2, whatever you want to write. And the final answer will be 42326. I have written on the screen, by the way, exactly Swamiji was telling. You can have our convenience, of course. You can say 20 minus 14 is 06, 30 minus 8 is 22, 45 minus 4 is 41, and 40 minus 2, 38, and write the answer. So there will be no question of part digits involving it. It's, of course, a way of writing of Swamiji. That is what I am saying. Not necessary, but it has some advantages, definitely. Try this. Now I will not show anything on the screen. I will wait for you till you get the answer. 5 times 8964 minus 2 times 1247. Write the parts of the products first. Then check your answer. I have done it in a usual way. On the right hand side, you can observe. I have not used bar digit in the answer. 20 minus 1406, that way, as I was saying. 45 minus 4 is 41, and 40 minus 2 is 38. You can have the answer, same answer, when you shift the digit. 42326. So I have given you both ways, practice for both ways. Same problem can be solved either on the left hand side or what is solved on the right hand side. Next example. Start writing the products straight away. 11 into 8, 88. That way. Six into 76 will give me 42 and 36 with minus sign. And 5 into 29 will give me 10 and 45. Add and subtract simultaneously. You can say 5 plus 4, 9, and 9 minus 6, 7. Oh, sorry, 9 minus 6, 3. Straight away. 4 plus 4, 8, 8 minus 3, 5. Or 4 minus 3, 1, 1 plus 4, 5. Whatever you want to go by. 8 minus 2, 6. 6 plus 0, 6. 8 minus 4, 4. 4 plus 1, 5. So 56 and 53. 5 transfer to left side will give me 613. See how easily we can do addition and subtraction and product simultaneously. Otherwise, you will take more time than what we have done to get the answer 613. Try this. 7 times 265 plus 6 times 89 minus 4 times 130. I will wait for you. Do write the product place wise, particularly for the second 6 into 89. When we add and subtract, rightmost, 78 middle part, and 10 left part. Answer is 1869. Again, some examples for practice. Just write them with answers. One thing before I move to the next slide is the third example, where you will observe that answer is minus 282. That is to be taken care of correctly. Other 3 answers are positive numbers. Now we move to the next case of our product addition and subtraction simultaneously. Now we have a 2-digit multiplier and 2-digit multiplier. Up till now we have only 1-digit multiplier. So things are comparatively easy because we know the multiplication table for each of it. Now, if the 2-digit multiplier is 62, naturally we don't, at least I don't have the multiplication table for 62. So I have to do by Urva-Tiryak method. Let us revise that what we have done yesterday. 58 into 27. 3 parts are suggested. First part 8 into 7, 56. Second part 5 into 2 plus 7 into 8. Sorry, 5 into 7 plus 2 into 8. And third part 5 into 2. Or if I want to write left to right, I can say 5 into 2 first part, 8 into 2 plus 5 into 7 middle part, and 8 into 7 right part. It is always easy to write from left to right. So I suggest to write the parts 5 into 2, 8 into 2 plus 5 into 7, or you can say 5 into 7 plus 8 into 2, whatever way, and then 8 into 7. Answers are 10, 51, 56. Shift digit wise from right to left now, 6 as it is. 5 plus 1, 6. 5 plus 10, 15. So answer is 1566. That is what we have done already. You might have done, you might have written the digits one below another, 58 multiplied by 27, and vertically and crosswise. Same idea here, nothing special. First vertical product, second part is the cross product and addition, third part is again a vertical multiplication. Just a mode of writing I have changed so that I can add and multiply simultaneously. That is the only reason why I changed the mode of writing. Otherwise, sutra is same, urdhva vertically and crosswise, same way of the product. Let us move one more. 16 into 72. 1 into 7, 7. 6 into 7 plus 2 and 6 into 2. 7, 44, 12 will give me the answer 2, 5, 11. When I shift the digits right to left, 1152 is the answer. Just to have some practice of writing horizontally, I am giving the examples. Try this. 61 into 49. 6 into 4, 24. 58 and 09. 24, 58, 09. Yes, 54 plus 4 is 58 and 09. When added horizontally, partwise, 2989. 5 plus 24 gives me 29 and 89. Try this. Just a practice. 37 into 92. 27. 69. 14 are the parts. Partwise addition give me 9404. Sorry, there is a mistake in typing. It should be 4 correct. Yes, it is 34, not 94. Sorry for that. Answer will be 3404, not 9404. One important thing which I want to note is when multiplication has two parts, 2-digit multiplication, and multiplier is also 2-digit, multiplicand and multiplier both are of 2-digit number, then number of parts will be 2 plus 2 minus 1. That is 3 parts. And you can check this from the previous example. So number of parts can be easily guessed by observing the number of digits in the multiplier and multiplicand. If I have 3 digits multiplicand and 4-digit multiplier, then 3 plus 4 minus 1, 6 parts will be there for my urdhva multiplication. But today at least we will be taking initially examples where 2 into 2 case is there. 2-digit multiplier, 2-digit multiplicand, so that every time I will have 3 parts. But as the class proceeds, we may get different situations. Now we will have sum and difference of the products with 2-digit multiplier. Find 45 into 27 plus 71 into 14. First, I will write the parts for 45 into 27. Start writing. 4 into 2, 8. 4 into 7 plus 5 into 2 will give me 38. And 5 into 7, 35. 10 plus 28 will be 38 and 35. For second multiplication, the parts are 7, 29 and 04. Middle part is to be taken care of, 28 plus 1. Always check whether we have written it correctly, because left and right is the straight multiplication. Now add partwise and shift the digits. 9, 0, 22. So 2209 is the answer. 9 as it is. 3 plus 7, 10. I write 0. 6 plus 1, 7 shifted to 15. Gives me 22. 2209. Next. 61 into 49 plus 37 into 92. Write the products. The parts for first multiplication are 24, 58, 09. I'm sure you will be able to write it correctly. For the second, 27, 69. Yes, 63 plus 6, correct. And 14. Vertical addition and then horizontal. Again, the middle part has 3-digit number 128. So 3 as it is. 8 plus 1, 9. And shift 12 plus 51. Always written one digit. All remaining, there may be 1, 2 or 3, are to be shifted to immediate left part. This way. And the answer is 6393. Now the difference. Idea is same. First, Urdhva-Tiryak parts. Add or subtract vertically and shift the digits. 81 into 35. So 24, 43, 43 is correct. 40 plus 3 and 05. 42 into 27 is 8, 32 and 14. My practice is of writing bar over the digit. You can avoid that, as I said. But when I subtract 5 and 14, I have to write minus 11. I avoid that. 5 minus 4, 1 and 0 minus 1 minus 1. That use of bar digit is useful here at least. 3 bar 2, 1, 4 bar 3, 1. 4 plus bar 8 is bar 4. 2 plus 0 is 0. Now I shift the digit. 1 as it is. Bar 1 plus 1 will become 0. And 1 plus bar 4 is bar 3. So first my shifting will give me 2 bar 3, 0, 1. 2 bar 3 means 20 minus 3. As I said, don't touch two positive digits on the right part. It is only the left part which is to be observed. 2 bar 3 is 17, 20 minus 3. So answer is 1701. As I repeatedly saying, you can subtract and then accordingly shift the digit. When you are getting minus 11 in the right part, while shifting, both digits are to be considered minus. If you write minus 9 as an answer, so bar 0 and bar 9, that way also you can write. There are many alternatives available. Always try this. This is slightly difficult, plus and minus both, and 2-digit multipliers and multiplicand. Go slow, go correct. I will answer all your queries at the end of my session. Please keep the queries with you. I will answer everything. Only because they are all new situations, we are not familiar with the such type of calculations. So you must get the difficulties. That's a good sign rather, that you are questioning something. The products are like this. Parts. Part 1, 24, 56, 16. For second multiplication, it is 6, 17, 12. It is plus. And then minus 45 into 13. So I have written 0, 4, bar 1, bar 7, bar 1, bar 5. Now 6 plus 2, 8. 8 minus 5, 3. 1, 6, 5, 6, and 2. All positive. When I add vertically, digit wise. One bar 1 will get cancelled. 7 bar 1, 7 gets cancelled. That way. So 26, 56, 13 gives me 3173. Again, I have some examples for you as a practice. Please note them and try to write the answers. I'm sure you must have written all the 5 examples with answers. We end this session with 3-digit multiplier. Or what's the time now? Okay, it is 3 o'clock. We will have a 5 to 7 minutes break first, and then we will begin with sum or difference of the products. It's okay, ma'am?
Yes, sir. Absolutely, sir. No problem.
Okay. I will come back up after 5 minutes.
Okay, sir.
I will keep the slide as it is. I will just
Yeah.
Okay, welcome all of you now. Please attend the screen.
Ji, sir.
May I start, sir?
Ji, sir. Ji, sir. If you are comfort, sir, then you start, sir.
Okay. Yes, I am comfortable. No issue.
Okay. Okay, sir.
After practicing sums and products, sum and difference of the products for 1 and 2 digits, now we move to the cases where multiplier has 3 or more digits. We will start with examples straight away. First, yes, I will 3 into 3 multiplication first, 1 or 2 examples, followed by the products and their addition. 234 into 781. When we write horizontally, we will apply the same idea. Leftmost to right. 2 into 7, first part, that is 14. Then 2 into 8 plus 3 into 7, same as we have done for 2 digits. That is 16 plus 21. Middle part is important to visualize and write. See what I am saying about the middle part. 2 into 1 is 2. And 4 into 7 is 28. That's as usual. In addition to that, 3 into 8, 24. So 2 crosses and 1 vertical multiplication. 2 into 1, 2. Right part is the only thing which is new, that is to be written correctly as 24. I repeat how I am getting 24. 8 into 3, 24. And middle part, 2 into 1 plus 7 into 4. Sorry, 7 into 3. Now we come to the third part. Now I have 34 and 81 with me. As usual, I will multiply 3 to 1. That will give me 3 plus 4 to 8, 32. And the last part is 4 multiplied by 1, 0, 4. I repeat how I am writing. 2 into 7, 14. 2 into 8, 16 plus 7 into 3, 21. Now, 2 into 1, 2 plus 8 into 3, 24 plus 4 into 7, 28. Now 34 and 81. So 3 into 1 plus 8 into 4. And lastly, 4 into 1. If you cannot write horizontally for the first time, then you can write 234 below that 781 and apply the things. So final answer for the parts is 14, 37, 54, 35, 04. Now 5 parts are to be added from right to left, 4 as it is. 0 plus 5, 5. 3 plus 4, 7. 5 plus 7, 12. 1 carry. So 4 plus 14, 18. Final answer 182,754. Initially, I understand while we write horizontally, particularly the middle part, you may get some difficulties in observation. Otherwise, for other parts, it is either 1 into 1 or 2 into 2. So two extreme parts are to be multiplied and added, plus the middle part multiplication. That is to be remembered. Now we come to our main issue. It's a difficult example, no doubt. 532 into 128 plus 462 into 245. We will go little slow. Write the 5 parts for the first product. Start 5 into 1, 5. This 5 into 1, 5. Now consider 53 and 12 for cross product. So 5 into 2 plus 1 into 3, 13. Now extreme digits are to be multiplied. 5 into 8, 40. 1 into 2, 2, that is 42. Plus 3 into 6, 6. 3 into 2, 6. So that becomes 48. That way, middle part is 48. Then for 32 and 28, it is 24 plus 4, 28. And 2 into 8, 16. Now write the 5 parts for the remaining product. First, 4 are easy. 4 into 2, 8. Take your time. Five into 10. 5 into 2, 10. Last part. Again, I repeat for the middle part. 4 into 5, 20. Plus 4 into 6, 24. Sorry. 4 into 5 plus 2 into 2 plus 6 into 4. That becomes 48. When we add now, we will get 13, 41, 96, 66, and 26. Vertical addition. This demands little practice, no doubt about that. And a correct observation. Shifting of the digit will give me the answer 181286. 6 as it is, 6 plus 2, 8. 96 plus 6 will become 102. 2 I will keep. 10 shifted to 51, that becomes 51. I will keep 1. 13 plus 5, 18. Whatever we had done for the addition, we will do for subtraction. So next problem, 237 into 54 minus 132 into 205. Now a change. It is only 54, not a 3-digit. So to avoid any confusion, we assume 54 as 054. So that we can write the product easily. It's a convenience, not compulsory. If you write 0 before 5 to the left of 5, then it will be easy to locate the parts and write the answer. I suggest that way. 2 into 0, 0. See what I am doing. 2 into 0, 0. Then 2 into 5, 10, because 3 into 0 will be 0. And then other 3 parts. For 132 into 205, no question. 2 into 1, first part. 6 will be second. 9 will be third. 5 into 3, 15. And 5 into 2, 10. Vertical subtraction, or write minus minus every digit as a bar digit and apply the subtraction. Any one way, as I said. You can straightway say 28 minus 10 equal to 18. No issue. I again insist on digit-wise subtraction so that it will you will get the answer quickly rather than thinking of what will be the answer and then carry anything. Here you need not carry anything. Just drop the value of the subtraction in the answer line. 7 minus 5, 2, 4 minus 1, 3, 3 minus 9 are 6, that way. Now we observe that the leftmost part is a bar digit, bar 2. So we shift as usual, 8, 2 plus 1, 3. 3 and bar 6 will give me bar 3. 2 plus bar 6 will give me bar 4. And 1 plus bar 2 will give me bar 1. So when I shift the digits, I will have this situation. And this is new to us. Every problem I have selected to give you one idea of how to tackle any situation if at all it appears. This is for the first time that we have a situation where leftmost or highest place digit is a bar digit. When highest place digit is a bar digit, it indicates that the number it representing is a negative number because highest place has a negative plus value. That is the reason. It will be minus 1 into 10 to the power 5. So when I add remaining places, it will be definitely a negative number. But then to deal with such type of numbers easily, similar to we take minus sign common, we will take that bar as a minus sign and transfer bar digit to normal digit and normal digit to bar digit. So bar 1, bar 2, bar 4, bar 3, 3, 8. We will write minus of 1, 4, 3. Bar digit converted to normal digit. And 3, 8 are normal digit. We will write bar 3, bar 8. It is just like taking minus 1 common from the series of numbers. So this way, minus of 1, 4, 3, bar 3, bar 8. Now I can convert that number to normal digit. Minus sign as it is. Now last two digit are bar digit. It is 300 minus 38. With a minus sign, I will get 1, 4, 2, 6, 2. It is 300 minus 38 gives me 262. 14 as it is. I agree because we are not familiar with these situations. You will face some difficulties, but have a patience, have a practice, have a concentration. You will get the correct answer. Once you start getting correct answer, speed will automatically increase. Try this. Just write as an exercise and then answers also. And try as much as example possible, at least for 3 into 3. So that you will get a good command over the calculations. Now we come to the second part of our discussion, sum and difference of products of algebraic expression. They are easy. You will not believe me. Calculations are easy for algebraic multiplications than numbers. Again, we'll start with the linear equations, then quadratic, cubic, etc. Same as first 1 digit, 1 digit, 2 digit, 3 digit. We will move that way. Sutra is same. Urdhva Tiryakham, vertically and crosswise. We start with simple example. X into 5 multiplied by x into 7. We can do it immediately, I know. But how Urdhva Tiryak gets applicable here? In the algebraic expression, we will apply Urdhva Tiryak Sutra, vertically and crosswise, for the coefficients and constants. So coefficient of x is 1 and 1. So 1 into 1 becomes the first part. Middle part 1 into 7 plus 1 into 5, crosswise multiplication. And the third part 5 into 7. Same Urdhva Tiryak, as though it is an algebraic expression, we will concentrate on the coefficients 1 and 1 and 5 and 7 constant and apply the same vertical crosswise. Answer will be 1 into 1, 1 x square, 7x plus 5x, and 5 into 7. The final will be x square plus 12x plus 35. Now observe the interrelation. When it is a decimal system, I take x is equal to 10 because that is the radix for or base for decimal system. So x plus 5 in decimal system is 15. X plus 7 is 17. So whatever I have done for 15 into 17, I am doing it for x plus 5 into x plus 7. But here there is no question of adding partwise, etc. I have to keep the parts as they are. X square, x into x, 7x plus 5x, 12x, and 5 into 7, 35. Again, if I put x is equal to 10 in the answer, that is 100 plus 120 plus 35, I will definitely get the answer for 15 into 17. They are that way interconnected by Urdhva Tiryak method. Second, what is the difference between numbers and algebraic expression is you may get a term like 4x minus 1. It is exactly 4 bar 1 in our case. That is why I was insisting there to use bar digits. So 4x minus 1 means 4 bar 1. Now same three parts, 2 into 4, 8. 20 minus 2, 18x. And 5 into minus 1, minus 5. So my answer is 8x square plus 18x minus 5. Same sutra, vertically and crosswise. Now try this. It is again product and addition simultaneously. Don't get scared with this. I will write the 3 parts of first multiplication. Below that, 3 parts of the second multiplication. Same idea. Add vertically, full stop. No, not necessary to shift any digit anywhere. Only like coefficients are to be added. So x into x, x square, first part. 3x plus 8x, 11x, middle part. Plus 24, second part. I will get for the first expression, x square plus 11x plus 24, straight away. 6x, 8 plus 15, 23, and 5 into 4, 20. Usual addition, add like terms to have the answer 7x square plus 44x plus 44. After good practice, what I will do is like this. Just listen what I am saying. When I want to perform such product plus addition, I will do. I know I need to add like terms. So 1 into 1, 1. 2 into 3, 6. That becomes 7x square. Okay. 3x plus 8x, 11 plus 6 plus 10 that becomes 44. 8 into 3 plus 5 into 4, 44. So my answer is 7x square plus 44x plus 44. But don't jump. Have a good practice, good observation, and then you start writing the answer by observations only. Try this. 3x minus 4 into 2x plus 7. Because there is no question of shifting the digit anywhere, the steps are less, answers are easily available. 3x minus 4 multiplied by 2x plus 7. Write the products. 6x square, 21 minus 8, 13 with plus sign, and minus 28 are the three parts for first product. Plus 20x square, 5 minus 8 gives me minus 3, 1 into minus 2, minus 2. Vertical addition of like terms. 26, 10, minus 30. So 26x square plus 10x minus 30. Try your luck with minus now. Don't worry, you have to write the minus. 5x plus 3 into x minus 5 minus 4x minus 1 into 7x plus 6. 5x square, first part. 5 minus 15 is minus 10x and minus 15. Remember, now I have to subtract minus. So 7 into 4, 28x square, but I am writing minus 28 because I need to subtract. Change the sign or write the minus sign common and the product, whatever way you like. Middle part gives me 14x, but because I need to subtract, I am writing minus 14. Third part gives me minus 6 answer. Behind that, there is a minus sign, so plus 6. Now add the like terms. Minus 9, minus 36, and minus 23 are the respective vertical addition to have the answer minus 23x, minus 36x, and minus 9. It's a method of writing only, and you can see the connection between algebra and arithmetic in decimal system at least. Try this. 7x plus 5 multiplied by 2x plus 3 minus 3x plus 2 multiplied by 2x plus 7. Those who can do it directly, like this, 14 minus 6, 8x square. You can see that way. 7 into 2 minus 3 into 2. They are the like terms. Can write the answer in one line. Or go by steps. First write the three products, then subtraction, and then vertical addition. Eight x square plus 6x, plus 1. Now there are three terms for addition and subtraction. Same idea. One by one, write the three parts, add and subtract. Vertically first, and stop. Like terms are to be added or subtracted. Coefficients of x square are to be added, then coefficients of x are to be added, and then the constant terms are added and subtracted. First one is simple, 6x square plus 3x minus 15. Yes. There is a mistake, 6x square plus, it should be 13x and minus 15. That way you write the correct answer. It's a typing mistake, it is not 3x, but 6 minus 15 plus 18 and minus 5. It is plus 13. Plus 13 means it will be 10x here. So 5x square plus 10x minus 24. Now we come to quadratic multiplied by quadratic polynomial. It is the same case as 3 into 3. You now will realize that x square plus 5x plus 3 means nothing but 100 plus 10 plus 3. If x is equal to 10 is there. X square means 100 in decimal system. Same 5 parts again. First part, x into x square into x square, x to the power 4. Then cubic part, x square into x plus 5 into x square. I have written that way. 1 plus 5. I am taking the cross products with the coefficients only by writing the x4, x cube, x square, x and constant. Middle part will be minus 5 plus 3 plus 5. Same as 3 by 3. Vertically and crosswise. Now consider 5x plus 3 and x minus 5. That gives me minus 25 plus 3 x. And lastly, minus 15. There will be 5 parts. It will be a 4-degree polynomial. So 5 parts will be there. 5 terms will be there, not parts. In case of numbers, we have parts. That plus sign in between them, we are separated by that colons. Answer is x to the power 4 plus 6 times x cube plus 3x square minus 22x minus 15. Same idea again is extended here also for addition and subtraction of the polynomial terms like this. A little bigger example. Each example has 3 terms. Write the example first. X square plus 5x minus 1 multiplied by x square minus x plus 7 plus in bracket 2x square plus 4x plus 1 multiplied by x square minus 5x plus 4. Don't jump to direct answer. First try stepwise. After practice, you can have a one-line answer anytime. Because like terms are to be added and subtracted. In algebra, as I'm repeatedly saying, it is easy to observe the like terms than the numbers. So first is x to the power of 4, 4x cube then 7 minus 5 minus 1 That's why x square 35 plus 1 is 36 and minus 1. Same for the second product, 2x square ten minus 4 minus 10 plus 4 minus 6, then minus 11. Yes, 20 minus 9 is minus 11. 16 minus 5 is plus 11. And 4 into 1 is plus 4. Add term wise. Final answer, 3x to the power 4 minus 2x cube minus 10x square plus 47x plus minus 3. That's right. Now in the last part of our chapter, within the remaining 10-15 minutes, yes, 20 minutes are there, we will be dealing with the square of the two-digit number by Nichilam Sutra. We require always square of the number in many calculations. So one method we will be studying today. Remaining 1 or 2 methods will be discussed in next lectures. It is easy to find square of two-digit number by Nichilam Sutra. That's why I will go to straight away. Consider a two-digit number A2 and A1. A1 is unit plus digit, A2 is tens plus digit. For square, we need to find. The step number 1 is select nearest less subbase. And that subbase will be 10 times A2 for 2 digit. Means if it is 52, my base will be 5 into 10, that is 50. Second step is find the deviation. Means the difference. That deviation is A2 A1 minus that base. Or in short, 10 A2 plus A1 minus 10 A2. So my deviation will be A1 finally. So it is easy. Base is 10 into 80 and deviation is A1. Always for A2 A1, base will be A2 times 10 and deviation will be A1. Now with this, I write a square. 2 parts. A2 multiplied by A2 A1, that number complete, plus deviation is my left part. In examples, you will get a clear idea. Just write first so that you will remember what to do. A2 times A2 A1 plus A1, left part, colon. To the right part, I will write square of the unit plus, that is A1 square. Now here, the thumb rule is right part will have 1 digit always. Means if my number is 52, I will have 4. But if my number is 59, A1 square will be 81. So rule gets applied there. And the same idea as we have done earlier, excess digit of the 91 by keeping 1 as it is. I will shift 9 to left part, add it, I will get the answer. Excess digits are to be passed to left part and added. So sometimes right part will have 1 digit. You need not change anything, write the answer. If right part has 2 digits, by keeping the rightmost digit, shift the left digit to first part, add it for the answer. So I repeat, A2 A1 base 10 times A2 I need not worry about the base now. For A2, A1, I start writing A2 times that number plus A1 colon A1 square. That is how that Nicolam method works. This is of course a theoretical part of that method. Now examples. 37 square. 3 into 10, 30 will be my base. Deviation is 7, 37 minus 30. Or that way also you can say A1 is 7, so directly 7 or 37 minus 7. And the answer for 37 square will be written like this. 3 times A2, 37 plus 7, it is that number plus deviation, left part, colon 7 square. So I have to only multiply 3 times 37 plus 7, that is 44 and 49. So my answer is 1322 colon any left part and right part is 49. My rule is right part should have 1 digit. So I transfer that 4 to left part to have the final answer 1369. 1369. So after practice, you can straight away write 3 times 37 plus 7. You start writing the square. 3 times 30 only by observing the number. 3 times 37 plus 7, first part, second part, 7 square. Then 3 times 44, 132, 49, and 1369. But in initial examples, 2 or 3, do write every step so that the concept will be clear. 54 square. Deviation 4 or A1, whatever you want to look to that. 54 square will be 5 times 54 plus 4, which is a deviation, left part, and 4 square right part. So 58 into 5 will give me 290, 16. 1 shifted to left part, 2916 is the answer. If in place of 54, I have 51, I will get 1 square. That 1 square, I can always write 0, 1, if at all we want to write. And then 1 as it is, 0 transfer to left, I will get 2901 or 51. So that depends on which number is at the unit place. Will decide how many parts are there in the right part of the square. Try 89 square. Go fast little. 8 times 89 plus 9, 9 square. 8 times 91, 81. 784, 81. 8 transferred to left part gives me 7921 as the answer. As I said, after practice, you can jump over the steps. And every time 50% time will be saved. Now another way. I can select 90 as a base, which is nearer to 89, instead of selecting nearest lower base. When I select a base as 80, I'm selecting base nearest less. 89 के लिए 80. But if I want to select the nearest or closest base, I can even select a 90. But once I select a best 90, my deviation will be 89 minus 90 and not 80 as in the previous case. Nothing to worry about it. Idea remains the same. But because base is 9 into 10, I will not start from 8, but it will be 9 times 89 minus 1. That is to be clearly understood. Our base in the previous case is 8 into 10. So I started with 8. But my base is 9 into 10. I will start with 9. 89 minus deviation and minus 1 square. I will get the same answer. This is more easy only because I need not worry about 8 times 98. Here I will get the product 9 times 88 and the answer 7921. So it is our choice whether to select a nearest less best or a nearest greater best. But I will advise, though I have given you the idea, my advice is always select a lower best so that a continuity will be maintained. Sometimes higher best, sometimes lower best. That may give you some confusion. But of course, practice makes the perfect. Now we come to sum and difference. Same idea again. 37 square plus 24 square. Start writing the parts for 37 square. How I will write? 3 times 37 plus 7. Left part. Right part 7 square. So 3 times 44. Even I directly says 37 plus 7, 44. I can write that way. So for 37 square, parts are 132 and 49. For 24, it will be 2 times 28 is 56 and 16. I hope you are able to observe. 2 into 28. 28 is 24 plus 4. Deviation is to be added. Then 4 square is 16. Now, same procedure. Vertical addition. 65 and 188. Shift the digit. 6 shifted to 188 gives me 194 and 5 as the answer. 1945 is the answer for 37 square plus 24 square. Hope you are enjoying this. 42 square plus 71 square. Don't wait for me. 4 times 44 to square. 176, 04. 7 times 72 and 1 square. 504 and 1. Vertical addition gives me 680 and 05. I'm purposely writing 04 and 01 so that I will be able to shift the digits easily. 6804 answer. Whatever we are doing for plus, we will do for minus. Same idea continues. First write the parts of 83 square and minus 58 square parts. Eight times 86 is 688. 3 square is 9. 5 times 58 plus 8 is 66. 5 times 66 is 330. 64. Now subtraction. You can subtract digit wise by using the bar digit. So 9 minus 4, 5. 0 minus 6, bar 6. I advise that way. 8 minus 0, 8. 8 minus 3, 5. 6 minus 3, 3. Don't go for carry digit. It will give you some complicated things. Now 5 as it is. Bar 6 shifted to left part. It is added to 8. That becomes 2. Because it will be 8 minus 6. So my final answer is 3, 5, 2, 5. Always practice of writing digit-wise subtraction. Whenever it is a negative, write a bar, so that the shifting of digit will give you the easy way. Last one for today's session. 16 square plus 51 square minus 32 square. For 16, it is 22, 36, no issue. 1 into 22 and 60. For 51 also, 5 into 52 plus 1 square, 260 and 0, 1. For 32, it will be 3 times 34 plus 4, that is 102. But remember, third is minus. So 6 plus 1 minus 4, 3. Go by that way. 6 plus 1, 7, 7 minus 4, 3. 3 as it is, plus 0 minus 0, no issue. 2 minus 2, 0. 2 plus 6, 8. 8 minus 0, 8. And 2 minus 1, 1. So minus parts, vertical addition subtraction gives me digit wise 18033. It is not 18,000. It is 1801 part, 33 another part. So don't mix. Now add part wise by shifting 3. Answer will be 1833. I'm not sure I have the problems now. Okay, yes, I have. Just for an exercise, you can write some examples, plus minus both. Sum of the squares and sum and difference of the square. And try your luck with the answers. I'm not providing them. Okay. Thank you very much for very patient listening and excellent cooperation to all the participants. I'm also grateful to all the authorities of University and Department of Mathematics, all the faculty members attending this session. Thank you.
थैंक यू मैंने सभी ऑडियंस को क्वेश्चनिंग के लिए ओपन कर दिया है.
ओके
जो भी स्टूडेंट्स चाहें अपनी क्वेश्चनिंग के लिए तो वो कर सकते हैं प्लीज.
यस,
एनी क्वेश्चन फ्रॉम द ऑडियंस साइड प्लीज.
Sir, can we get this presentation on our email ID?
Yeah, of course.
All the presentation which we have, sir, as
एक्चुअली बहुत सारे लोगों ने ना, मैंने अनम्यूट किया तो उन्होंने दाएं बाएं की एक्टिविटी को सुनना शुरू कर दिया. आपका क्वेश्चन मैं समझ पाया कि आप कह रहे थे कि आपको पीपीटी चाहिए. हम सर से रिक्वेस्ट करेंगे, आपको पीपीटी मिलेगी और इस फॉर्म में नहीं मिलेगी तो आपको कोई ना कोई आइडिया जरूर मिलेगा. प्लीज बी इन टच, नो प्रॉब्लम. आप मैसेज कर सकते हैं अगर कोई और आपकी क्यूरी है तो. अनम्यूट करते ही तो पता नहीं.
yes.
सर, ऑल द प्रीवियस लेक्चर एंड अपकमिंग लेक्चर. यस जयवीर जी, ऑफ कोर्स वी विल प्रोवाइड यू एज वेल एज व्हेन वी गेट. वेरी नाइस सर. यहाँ पे मैसेजेस रिसीव हो रहे हैं बहुत सारे स्टूडेंट्स के, बहुत सारे कलीग्स के. वो बहुत ही अच्छे से धन्यवाद बोल रहे हैं आपका. आपने किस तरीके से बिल्कुल सरल सरल तरीके से आपने वैदिक मैथमेटिक्स की पावर को टच किया। रियली ए ब्यूटीफुल सर।
थैंक यू।
इसमें सर मैं एक क्वेश्चन ये पूछना चाह रहा था सर,
हाँ
जैसे आप लोग जो नंबर सिस्टम पे काम करते हैं वो सारे के सारे शायद इंटीजर ही हैं, फ्रैक्शनल नंबर पे काम नहीं है शायद इसका। तो सर वैदिक में हम फ्रैक्शनल नंबर को भी कंट्रोल कर लेते हैं?
हाँ हाँ करते हैं। यस देयर आर मेथड्स।
ओके ओके ओके, ठीक है सर।
और फ्रैक्शन को कंटिन्यू करते हैं, और डेसिमल के लिए ज्यादा प्रॉब्लम नहीं है। सेम सूत्र इज एप्लीकेबल इफ द प्रोडक्ट
Okay.
इज से 31.4 मल्टीप्लाइड बाय 28.6। सेम
Oh.
सूत्र एप्लीकेबल।
Oh.
Only thing we have to place a decimal point at a proper place at the end of multiplication.
अरे so nice of you sir, thank you sir. सर एट द लास्ट मैं आपको फिर से अपने तहे दिल से शुक्रिया अदा करता हूँ, आपने इतना टाइम दिया और सर आपने वैदिक मैथमेटिक्स की इस पावर से हमें अवगत कराया। ये जो भी ऑडियंस हमारे साथ जुड़े हुए हैं जरूर ये इसका फायदा उठाएंगे और हमारे साथ टच में बने रहेंगे। सर अब आपके लेक्चर जहाँ पे भी हो इंडिया लेवल पे और आउट ऑफ इंडिया, जस्ट हमें थोड़ा सा मैसेज कन्वे करते रहना ताकि हम बार बार आपको सुनते रहे।
ठीक है। थैंक यू सर, थैंक यू।
जैसे ही
थैंक्स
सर
फॉर द कॉम्प्लीमेंट।
यूनिवर्सिटी, जी सर, जैसे ही यूनिवर्सिटी की सिचुएशन ओपन होंगी सर तो हम फिजिकली आपसे रिक्वेस्ट करेंगे आप फिजिकली भी आएं। और
ठीक है।
जी
आई
सर,
विल बी देयर। नाउ आई एम
जी
रिटायर्ड सो आई कैन कम टू योर प्लेस आल्सो।
अरे सर रिटायर तो सर आदमी जॉब से एक पर्टिकुलर जॉब से होता है, कर्म से थोड़ी होता है सर। आप इतना काम कर रहे हैं सर।
रिटायर्ड बाय नॉट ओनली माय कॉलेज वर्क इज ओवर।
यस
रेगुलर
सर,
कॉलेज
यू आर
वर्क
ग्रेट
इज
सर,
ओवर। रेस्ट
ग्रेट
इज
वर्किंग सर।
एवरीथिंग फाइन।
जी सर, ओके सर, सो
ओके थैंक यू।
अगेन थैंक यू सर। ओके सर,
थैंक यू ऑल।
ओके
नाउ आई
ओके,
लीव।
जी सर, थैंक यू।
थैंक यू सर।
थैंक यू। थैंक
अरे
यू
मैडम
मैडम।
आप भी थे?
हाँ मैडम कुछ बोलना है?
नहीं शायद कोई और
Thank
बच्चे
you,
भी-
Dr. Barak, for this
हाँ हाँ
hospitality, and thank you for the speaker also for this nice presentation, sir. All the जो हमारे पास आज भी था टॉक्स हैं सारे YouTube पे लाइव हो रहे हैं, तो आप सब लोग हम उसको टेलीग्राम पे डाल रहे हैं, तो आप कभी भी सुन सकते हैं उसे।
और सर श्रीराम सर जी मैं आपको बताऊं,
हाँ
हमारे पास शिमला यूनिवर्सिटी से डॉक्टर विजेता पठानिया जुड़े हुए हैं।
अच्छा।
अलग अलग यूनिवर्सिटीज के टीचर जुड़े हुए हैं, मैं सबके नाम दूं तो काफी हो जाएंगे। आप ये ना सोचें कि सिर्फ एमडी ये आईजी यूनिवर्सिटी के ही स्टूडेंट इसमें इन्वॉल्व हैं।
नहीं
अलग
मैंने
अलग
कुछ पार्टिसिपेंट्स के नाम देखे थे उस दिन।
जी सर, जी सर,
आज तो नहीं देख पाया मैं कोई नाम।
जी सर, जी सर,
बोल रहा था तो।
जी सर।
आई थैंक एवरी फैकल्टी
Okay,
मेंबर
sir.
फ्रॉम ऑल द यूनिवर्सिटीज।
थैंक यू सर, थैंक यू सर।
ओके थैंक यू।